Hello everyone, welcome to the virtual laboratory demonstration from the Department of Electronics and Communication Engineering at Puchai Technological University. In this video, we'll perform the experiment on binary phase shift keying, also known as BPSK. Binary phase shift keying is a digital modulation technique in which the phase of the carrier signal changes according to the input binary data. Unlike FSK, where frequency changes, in BPSK the phase shifts between 0 degrees and 180 degrees. Here the aim of the experiment is to understand how binary data is transmitted using phase shifts and to observe the modulated waveform using a virtual oscilloscope. In BPSK modulation, the binary data is first converted into a polar NRZ signal where logic 1 is represented by positive voltage and logic 0 is represented by negative voltage. This signal is then multiplied with a carrier wave. When input bit is 1, the carrier remains unchanged. When input bit is 0, the carrier undergoes a 180-degree phase shift, meaning the waveform is inverted. This makes BPSK one of the most robust modulation techniques against noise. Now let us look at the procedure. First, we activate the system by clicking the blocks in sequence. Start with binary input, then NRZ encoder, followed by the BPSK modulator, and finally the oscilloscope. Once all the blocks are activated, the lab interface will be unlocked. After unlocking the lab interface, you can enter the inputs. For example, we can use a sequence like 10110001. Then we set the carrier frequency and the amplitude values. These parameters control the generated carrier signal. Now let's try running the simulation. As we saw in the procedure, let's try clicking the blocks in sequence. After unlocking the lab interface, we can enter the input. Now we click the update scope button to generate the waveforms. The oscilloscope will display different signals across multiple channels. The channel 1 shows the input signal in polar NRZ format where logic 1 is positive and logic 0 is negative. The channel 2 displays the carrier signal and the channel 3 shows the BPSK modulator output waveform. Here we can clearly observe that whenever the input bit changes, the waveform undergoes a 180-degree phase inversion. Now the channel 4 displays the constellation diagram where Channel 4 displays the constellation diagram which consists of 2 points representing the two phase states. In the results section, we can see a table that shows the mapping of each bit to its corresponding NRZ voltage and phase. Logic 1 corresponds to 0 degree phase and logic 0 corresponds to 180 degree phase shift. Thus, the experiment successfully demonstrates how binary phase shift keying modulates digital data by changing the phase of the carrier signal. This method is widely used in communication systems due to its robustness against noise. Thank you for watching this tutorial.